Students, if my voice is audible, so I am starting the class now. In the previous class, we have seen regarding the di diagram of an inducted system and the conventional fuels related some of the requirements and the details regarding the petrol, gas, LPG, and the CNG. Now we are going to study regarding the alternate fuels in spite of using an petrol or the diesel and the LPG. Okay, so the most commonly conventional fuels which are being used nowadays are the petrols and the diesels and the CNGs, and somewhere in the LPG gaskets are been also been used. Okay, nowadays there are some other alternate source of the fuels can be used for the automotives for the movements of the automotives or the engine runs. Okay, so what are the non-petroleum source? There are some of the non-petroleum source that are nothing but the methanol and the ethanol is an alcoholic base type liquid petroleum gas which has been also been used for the runnings of the engine. The LPG can also be used as an SI engine fuels. It consists in hydrocarbon. So see, the petrol is one of the hydrocarbon combinations. Okay, the petrol chemical composition is an hydrocarbon combination. So the LPG also works on the same chemical composition, that is a liquid petroleum gas works on the hydrocarbons that they exist as in gases under the atmospheric condition, can be readily liquefied under the pressure. So this gas can be liquefied under the high pressures and it can be used for the combustion of an its own in and for the running purposes also. Now there is an also another alternate source of an fuel. There is a possibility of using ammonia, CnH3 and benzol as a fuel in. Hello, it is audible? My sound is audible? Ammonia and benzonal as a fuel in an internal combustion engine. The benzonal has a very high knocking resistivity. So the benzonal is a fuel which is having a very high knocking resistivity. The knocking doesn't occur as compared to the SI engines. Okay, but it is not suitable for the cold climate as it has a freezing point 5.5 degrees Celsius. Okay, and the agents which are gas of lime. Now one more gas is there which can be used as an alternate fuel, that is an biogas engines. You have everybody have heard about the biogas engines. So these are the engines which are runs on the biogas. So what do you mean by the biogas? The gas which is generated by the vegetable soils and the whatever the compositions you are doing, the natural compositions of the vegetables or the trees. Okay, or by the sunflower seeds, peanut seeds, so oil. Okay, the groundnut oils by which. So these are the things which are being used for the combustions of the gases. So the vegetable oils have an ceten number greater than the 30. Okay, so they are process a better ignition qualities and the light alcohol in the diesel engines. Some of the example of the vegetable oils are some of the examples of the vegetable oils are peanuts, peanut oil, linseed oil and rapeseed oil, sunflower oil. The problem associates with the use of the vegetable oils are high viscosity that often diesel, causing a problem in fuel handling, pumping, slowing, burning, red causes the formation and the exhaust smoke and inflation. So see, nowadays, the petrol, diesel, LPG, and the CNG are the most commonly usable fuels which are being used on on this fuels only the automobiles engines are been running nowadays. So these are the alternate fuels having some of the similarity related to these types of fuel, but they doesn't work 100% or doesn't stand for the 100% for the running of the engine fuels, because each and every alternate fuels having its own disadvantage. If you take the biogas, the biogas can fulfill near about 80% the natural whatever the fuel conventional fuels nowadays are working, the demands or the requirements of the engine or the working of the engine or the test, it can conduct up to 80%. But the major disadvantage of the fuel is that it is very difficult to handle or carry the biogas. Okay. And another one alternate fuel, benzol. I know ammonia benzol is also one of the alternate fuel which can be used for the running of the which can be used for the running of an automotive. But what is the problem behind that? If there is a cold temperature or if there is a winter season, if the vehicle is there, so this fuel starts to freeze over there. It doesn't uh, convert into a liquid form or a gaseous form. It starts to freeze over there. For that reason, this is also not suitable for the working as a fuel. So alternate fuels having some of the major disadvantage. For that reason, nowadays or the present days, they are not used as a fuel for the running of the automobile. Still, there are so many research works are carried out to overcome the drawback of the alternate fuel, so that it can be used for the fuel in the upcoming days or in the future. Now we'll go for the next concept, that is an normal and abnormal combustion in the SI engine. So I will like to share another screen to you all for the normal and abnormal combustion of an engine. So there is a diagram I will show you, so it will help you is to understand more clearly. So in your screen you can see there is a diagram. At a diagram, so this is before going to this, so see this is a piston which is reciprocating within the cylinder. Okay, and this is an elliptical area by which you can understand how does the by which you can understand how does the combustion chamber works and the area of the combustion works. And this is some of the graph which has been shown over here. Okay, this is a graph which has been shown. Okay, over here BDC at the center, there is an TDC. Now this is a pressure and the time diagram is there. Okay, over here. Now see what is happening over here by this help of the cylinder. So this is the bottom is for the abnormal, and at the top it is for the normal. Okay, now if you see this diagram over here, I will try to take the next diagram. Okay, so you know there are the different strokes having their different works. Okay, in the combustion stage where the combustion is occurring over there the ignition delay is occurring, the preparation flame is occurring over here, preparation of flame is occurring over here after burning. Okay, so the knocking is occurring over here. So this is what the engine is there. So from the engine the piston is moving from BDC to TDC, from bottom dead center to, so see the piston is moving from bottom dead center to top dead center. At this moment what is happening over here during the combustion chamber, So when the piston is coming to this near to the spark plug, at that moment what happens, the spark is generated by the spark plug. When the spark is ignited by the spark plug, the spark or the flame get enters into this cylinder. Now you can see over here, this is what the cylinder space is there, or over here this is a cylinder space, it is shown in a circle or elliptical. In this space the air fuel mixture is been charged. In this space the air fuel mixture is been charged over there. Okay, charge means what? It is been supplied by this wall. This is an inlet wall, okay, by which the air fuel mixture is been supplied over here, and the spark is been ignited. It starts to pass, it starts its flame, okay, by this mixture. When it's come to this stage over here, okay, so you can see this is an end charge. When the fire flame is coming from over here, okay, the spark is coming from over here, when it comes at the top of the piston, at this top of the piston where the air fuel mixture is there, there the combustion starts. Okay, where from there where the air fuel mixture starts to burn over there, from this portion it starts to burn completely. When the pistons comes over here, the spark generate the compression pressure as well as the ignition, the air fuel mixture is been burned. It also compress the piston to move from TDC to once again at a BDC. Now you can see over here in this diagram. So see, from over here the BDC, the piston is moving. From over here you can see in the pressure time diagram, the piston is moving. When the pistons comes at this portion, okay, near to the TDC, when the pistons come near to the TDC, the ignition occurs. The ignition occurs by the spark plug. Okay, when the ignition is occurs, at that moment what is happen, the combustion of an air fuel mixture or the burning of an air fuel mixture is been formed. So see, from this to this up to over here the piston is moving in this. Okay, so this is the initial stage where the ignition is occur. From this ignition the flame starts to enter in the cylinder and it comes to this position, that is the piston. So this is what the piston head position is there. Okay, this is what the piston head position is there, where the fuel is starts to burn over there. Okay, at that moment what is happening over there, at that moment what is happening, the combustion is occurred over here, the fuel starts to burn, and once again when it's come to this peak point, when it comes to this peak point, it compresses the pressure to the pistons and allows the pistons to move at the bottom side, that is an TDC to BDC. Okay, so this is what the normal combustion occurs. Now we will go for the abnormal combustion. So what do you mean by the abnormal combustion? So see, the piston which is coming to near to the TDC, at that moment the spark plug is been ignited. Okay, then afterwards when the spark plug is ignited, the combustion of the air fuel is been done. Okay, then the compression stress is being generated or the pressure is being generated within the cylinder at the top of the pistons and make the pistons to move from TDC to PDC. Okay. Now, so see, this is a spark plug. Okay. Okay, in the previous diagram you have studied regarding the now just now I have told regarding the normal combustion. So what is happening in the abnormal combustions in the SI engine? So see, in the normal combustions, so this normal combustion is occurs. So see, the normal combustion occurs always at the initial stage of the engine, the initial stage of the engine where the engine is been starting. Okay, has the pickups takes by the engine, has the pickups takes by the engine. So the engine, the pistons movement and the crankshaft movements or the engine speed, the RPM is been increased over there. Okay, when it has been increased, so the intake of an air fuel mixture is also been increased and the combustion rate is also been increased over there. Okay, as the speed has been increased within this time, what is happening, within this time what is happening, so some amount of the air fuel mixture is been remain unburnt. Okay, which has been remained unburnt. Unburnt means what? Which has been not combust properly. Okay, that type of air fuel mixtures makes the in combustion, that types of air fuel mixtures make the abnormal combustion in the engines. Okay, which leads to the knocking and detonation within the engines. Now let us see how that air fuel mixture makes the abnormal combustion in the engines. So see, when the piston is moving at the upper side, at that moment what is happening over there, the air fuel mixture which is collected at the top of the piston, the air fuel mixture which is collected at the top of the mixture at the top of the piston. Okay, what is happening, when the fuel is starts to burn, okay, when the spark plug enters from this side, the flame starts to enter over this side. So this is what the normal combustion is been occur. But some of the air fuel mixtures which is collected at the head of the piston, at the head of the piston, okay, that also starts to burn, but it doesn't take the heat by the spark plug. Okay, that combustion, that fuel combustion is carried out due to the continuous movement of the piston. The temperature is been increased and the pressure is been increased. Due to the increased temperature burns the air fuel mixture in spite of burning by the spark plug. Okay, so this is been done. So this is been done within the SI engines, okay, by which the abnormal combustion is carried out. Okay, so I hope you are understanding everything. Okay, so see, today I am giving the second assignment for the automotive and I am also going to conclude your fourth model because 6th semester students are very clever students. Okay, and keep your mind, those who are sharing in the screen, what are you doing? So this is been recorded by me. Okay, every class yours are recorded and directly going to the principal. So we are doing our duty, and hopeless students like you are just, you are unbelievable. Okay, you are going to suffer. So within one day you are going to face the three internals. Within one day you are going to write the three internals, first, second and third. So there will be no mercy regarding the internals. You are, whatever the you are writing in the internals, that marks only given to you. Okay, no extra marks for the average. I hope you will get the average. So normal and abnormal, I hope you have understood. Okay, I am going further. Okay. Now this is a ceten number and the octane number. The ceten number and the octane numbers are nothing but a grade given for the fuels. Okay. So the ceten number is given and these are the grading numbers which are been given for the fuels. So see, each and every petrol fuels having their petrol and the diesel having their own ceten numbers and the octane numbers. So each and every automotive vehicles or the engines are being designed according to the required ceten number and the octane number. So what do you mean by the ceten number and octane number? So see, the fuel used for the rockets, the fuel used for the fighter jet, the fuel used for the aeroplanes, okay, are the petrol. Somewhat petrols are been, but they are having their own ceten numbers and the octane numbers on which they are being used. So what do you mean by the ceten number and the octane number? So the ceten number and the octane numbers are the numbers by which you can identify that fuels can be completely burned, or the combustion of an 100% fuels can be occur, so that you can have the economical combustions of the fuel. Okay, so the octane number, it is a fuel having a grade in an SI engine, CI engine. The fuel use of an fuel of an octane number. Okay, the larger number of an octane resists the detonation and less fuel burn resists the combustion. The higher compression ratio due to an higher compression fuel can be done. In CI, the lower number of the octane number, more fuel can be burns. Okay, I hope you are understanding because you are all the clever students. Okay, the lower number of the octane number, less resistance of a detonation and less fuel resistance of the combustions. Okay, if the octane number is lower, it is having the less resistance of the detonation and the less fuel resistance of an combustion. The reason air is compressed, okay, not in fuel, so when the fuel enters it can burn fast. For that reason the octane number is to be adopted. So now in an SI engine, the fuel resists the combustion due to the pressure of an compression. Okay, now keep in your mind, the combustion in the SI engine is obtained due to the pressure of the compression of an piston, and the heat is allowed the fuel to burn by an arc or the spark generated by the spark plug. So the less fuel burns over there. So the larger number octane number is been required in an SI engine. Okay. So this is what the important thing if you have to keep in your mind. So the octane number rating, how the octane number is to be identified. So see, the octane numbers can be identified by mixing two different types of fuel. One is an iso-octane anti-knocking fuel, that is an 100%. If you are using that fuel as an 100%, that second fuel you have to add, there is a normal ceten, a very poor oil which is an knocking fuel. Okay, if you add 50% of this normal hepatine with the 100% of isoacetylene, so 50 plus 100, how much it will be? 150. If you add if you add 50 plus 0, what will be? That will be the 50. Okay, if you add 150, so it acetylene number will be large, which makes the detonation and the knocking acetylene number. If you add 50 plus 0, that will be the 50 acetylene number, which makes the fuel ready for the combustion without knocking. Now let us go with the ceten number. Ceten number in the diesel engine, the ceten number is major for the ignition delay. So see, in the diesel engine, that is in CI engines where there is an ignition delay, the fuel is being combust due to the compression. The ceten number is made of an two different types of fuels, that is ceten is also called as a straight chain paraffin and straight chain paraffin assigns with a rating of 100 ceten number, and it is a good ignition quality. It is having a good ignition quality. It fixed with an alpha methyl naphthalene and hydrocarbon with a poor ignition quality, that is with a 0. So when you mix this 100% of an ceten plus alpha methanes with an 0 numbers, okay, so there is an CFR. CFR means what? Cooperative Fuel Research Institute is there, where the cetane and the octane numbers are been given for the fuels. Okay, and these fuels are being tested in an cooperative what you can the Cooperative Fuel Institute. Okay, where there is a special designs of the engines are being made. By on that special design engines, the cetanes and the octane numbers are being identified. Okay, then these numbers are being given to the particular fuel. Okay, cetane and octane numbers. So how these few numbers are being identified, just now I have told you, by by using two different types of fuel. One fuel is mixing with an other fuel, okay, by which having an anti-knocking, and another fuel is having an knocking phenomena. One is added by the 50-50%, then it has been said, then another one which is having the good quality numbers, that is been added by the 100%, then it has been given another fuel is been added by the 0%. Okay, by like this way the cetane and the octane numbers are been identified. So I have completed the cetane and octane number. Now the mixtures requirement for the SI engines. So see, the mixture of an fuel requirement for the SI engines are as follows. Okay, so what are the mixtures required? Air and the fuel, both the mixtures should be done properly for the SI, for the running of an SI engine. So this mixture is being carried out in a carburetor from where it is supplied to the engine. So there are the three conditions in which this mixture should be supplied properly. First one is an idling, crushing and high power. So what do you mean by the idling of an engine? The idling of an engine is nothing but the initial stage. At what moment initial stage idling and the lower so see, idling is nothing but the when you are the bicycle or the vehicle which is in the neutral position before putting in gear or the load on the engine. Okay, at the initial stage, that is when you take in a neutral and giving an accelerator, at that moment the carburetor is been stopped over there. From that carburetor no air fuel mixture is supplied to the engine, but the air fuel mixture is been burned inside the engine which is been stocked previously. Okay, previous when you have used that in when the engine is in running before starting. Okay, the air fuel mixture which has been residuals or been results in that engine cylinder which has been burned afterwards when you start the engine in an idling time. The bike or the vehicles which is in the neutral position, unload position, when you start the engine, okay, in a neutral condition, so that fuel is been burned which is in the cylinder, but air fuel mixture is not supplied by the carburetor. Keep in your mind. Okay, that is why when your bike, if you can see, when your bike is in the neutral position, okay, in the neutral gear, you are giving an accelerator to the bike, the smoke is coming out by the engine because the fresh or the proper air fuel is not supplied to the engine. So whatever the burned air is there, it is burning once again when the ignition is occur, by which the smoke is being produced or come out by the silencer, you can observe. Now in this idle load, then afterwards from the neutral, when you go for the first gear or you are putting the gears, okay, that is called as a normal power range or the crushing range. As the load increases beyond the 20% of the rate load, the dilutions of the residual gases means what, which are been already present in the engine cylinder which has not been inserted by the carburetor, or the air leakage decreases. In this range, the carburetor gives the maximum fuel economy. It occurs that the air fuel ratio goes up to 17 by 1. Okay, by this way the carburetor starts to release the air fuel ratio by 17 by the 1. Now when the maximum power ranges, when the engine starts to move at a top speed, when the load is been produced, at that moment what quantity of the air fuel mixture is been given, the maximum power is obtained at the top 13 by 1. The air fuel mixture maximum energy is released when a sliding excess fuel is introduced, so that all the oxygen present in the cylinder is been utilized.